All right, everybody, it's Professor Cooper again for data visualization. I'm going to talk about working with dates and time in lubridate. This will be really useful for some of the assignments that I give to my students. And so let's start by attaching the libraries. So tidyverse, and then we're going to use lubridate, which is in the tidyverse. But you need to call it separately. It's not one of the ones that automatically loads, as far as I recall. So I went ahead and called it separately, attached it separately. So let's look at the data. The data are coming from the Johns Hopkins GitHub. And I'm going to take, I've already done this, I'm going to do this again. So here's what it looks like. So I'm using the glimpse function, so it's, sideways. So we have province, state, country, region, lat, long. So there's 1 point per country / territory or province. And then individual dates. Variables are individual dates, but they're not actually in date format. And they have a number of cases. And so it starts, as you can see, with January 22nd, 2020. And it goes all the way to, let's see, I pulled this yesterday, so July 14th. So we can see the numbers as they evolve. And what I want to do is I want to get this into a format where I can plot, where I can make visualizations, also where I can do any sort of statistical procedures or anything like that I would like to do. So the first thing I'm going to do is I'm going to collapse all these dates into one variable, and then I'm going to transform the variable from a numeric or a double into an actual date, a date object, because you can actually plot time as date objects. And so we're going to do that. We're going to transform. Okay, so first we're going to use the pivot longer, which if you've been in this class, you should have already seen this in a previous video. But and I'm going to keep saving the objects, so I'm not just going to make copies and pipe through just yet. So you can see we start with the data set. We are using pivot longer. The arguments are names2, which is going to be the new sort of key variable called date. The values that are inside those are all going to go to the new variable called cases. And I'm selecting all the variables in a row that I'm going to collapse. Okay, so I've already run this, but I'll do it again. We can quickly look at, we can glimpse at COVID-2 now. And you can see date has now been collapsed. Afghanistan now has a repeat. And it goes all in one variable now. It is January 22nd, January 23rd, January 24th, and so on. And then the cases follow suit. All the variables that are not collapsed into the new variable are repeated for the number of observations. So the data set that is new is as many times longer as there were variables that became dates. So the number of dates multiplied the dimensions, the length of the data set by that many dates. So all the other variables that aren't dates just get copied that many times. Okay, so here's where the date stuff comes in. So right now, this date is in a format that is it's just a character string right now. Okay, and so it's not useful yet. We could do some stringer work and convert it into a numerical date that would work in order, or we could just use lubridate and use a few functions and extract and rearrange the date and get it into the right kind of object. so that we could do different kinds of analysis on it. And that's what we're going to do. Lubridate is really powerful. You can do lots of different things. Let's see, I have the cheat sheet pulled up here. You can pull any, you could really identify any sort of version of date format that you really want. But there is a sort of universal date format that's going to be used. You can store as time, as date time, and then you can easily extract. What we're really concerned with here are the parse date times, because we're trying to figure out how to pull out the proper pieces of the character string and convert it into a properly formatted date. So obviously YMD, Y stands for year, M month, D day. And you can rearrange that according to, and then HMS means hour, minute, second. You can get it all the way down to the hour, minute, and second if you have timestamps, or you can create timestamps for those that don't have them, but those would be useless because hour, minute, second would all be zeros. Now, so I'm taking the COVID-2, I'm going to make a copy of the data set called COVID-3, and here's where I start creating a bunch of different kinds of dates. Date 2 is going to take this date right here, and it's going to extract. We're looking at the pattern, we're saying, what is the pattern in the current version of the variable? So the current version of the variable is month, day, year. That's why here it's MDY. It's saying go in, find them in this pattern, MDY, month, day, year, and it will convert the original date variable into a properly formatted date variable. Okay. Now in the remainder of these here, I'm doing different forms of sort of collapsing. I'm extracting different elements, so I can take the new date variable that I just created, and I can assign a week, or what's called an ISO week, or an epidemiological week. So these are just different formats that start on different days of the week. Week starts from day 1 of that year and counts the number of complete weeks plus 1, and then it starts counting days. So it's not, so it depends on what you're doing, which one of those you would want to use, but they all will compile and collapse the dates into weeks. You'll see the difference shortly. And then you can also pull out the month, and it just pulls out the month based on the M part of the original date after you transformed it to date 2, in this case. And then I've got some other stuff going on here just to clean up the data. So do that, and then let's take a look at COVID-3. Let's see all the things that happened. Okay, here's the original date. Here you see this right here. This is where you find out the class of your variables, if you recall. This is the date format that is being recognized that can be used. You can take that and use that as your X variable in a ggplot, and it'll plot directly like it's a date in order, right? So date 2 worked. Then date week, you see it starts at 4 because it's at least 3 weeks since the beginning of the year, and then it starts counting in 7s, and it just upticks to the next week. So it could in theory be off by a day or 2 or 3 because it only counts on the complete weeks that happened before it. The ISO week does a slightly different version starting on Sunday. I believe one of the ISO and the EPI, one of them starts on a Sunday and one of them starts on a Monday. I guess we could look at it and figure that out actually. So this one starts, EPI starts on a Sunday, it looks like. ISO starts on a Monday, like business week. So if you're doing stock market stuff, you'll probably want ISO week, something like that. And then the month. The month just looks at, again, the M portion of the date and copies it. So these are 1s until February, and then it starts with 2s. So it's really that simple to sort of manipulate the date, the month, the day, the year. You can get it down to a timestamp with hours, minutes, and seconds. Lubridate has a lot of different functionalities, has a lot of different capabilities here. I encourage you to investigate lots of the other ones, but the ones that will be needed for my assignments will largely be the ones that I've shown you here, because there are some puzzles in some of the data sets, like this COVID data set that is part of one of your assignments. You can use lubridate to fix all those problems, and then you can move on to make some really good visualizations. So hopefully this is really helpful. Take care and see you.